Welcome. The topic of this video is evaluating an exponential function that represents a real-world situation. In the example question we'll be taking a look at, we're told, the radioactive substance uranium-240 has a half-life of 14 hours. The amount, A of T, of the sample of uranium-240 remaining in grams after T hours is given by the following exponential function. And we're given this function, A of T, or the amount, is equivalent to 1200 multiplied by 1/2 raised to the T over 14th power. And then we're asked, find the amount of the sample remaining after 11 hours and after 40 hours. And we're told to round the answer to the nearest gram as necessary. Okay, let's go over an explanation of how we can solve this problem. First, we find the amount present after 11 hours. To do this, we let t equals 11 and use a calculator to compute what A of 11 is. Okay, so to figure out what A of 11 is, all that we're doing is just plugging 11 in for t in the equation above. So, we want to evaluate, so we have 1200 multiplied by 1/2 raised to the 11/14th power. And that's equivalent to 696.0 and some change. So rounding that to the nearest gram, we would have 696 grams. Next, we want to find the amount present after 40 hours. Similarly, we want to find T of 40 now, and use a calculator to compute then A of 40, or the amount present after 40 hours. Again, we just want to replace T in the expression above with 40 now. So now I want to evaluate 1200 multiplied by 1/2 to the 40/14th power. And that's equivalent to 165.6. Then again, rounding to the nearest gram, we get 166 grams. So finally, the answer to our question would be, after 11 hours, there would be 696 grams present, and after 40 hours, there would be 166 grams present.